Hi, welcome to our channel True Up. Today we will discuss the rumored Foxconn introduction of mainland-made lithography machines by Taiwanese media. On December 5, Taiwan's Economic Daily News and United News Network reported simultaneously that Foxconn Group's first wafer-level packaging and testing plant, which officially opened on November 26 in Qingdao, introduced up to 46 sets of lithography manufactured by Shanghai Microelectronics. At the same time, it is claimed that this means the mainland's lithography machine has improved from 90 nanometers to 28 nanometers. According to Chinese media Observer, the semiconductor packaging and testing project co-founded by Foxconn and Qingdao State-Owned Assets Company Limited began introducing Shanghai Microelectronics lithography machine in July of this year. Taiwanese media mix up lithography machines for front-end manufacturing and lithography machines for back-end packaging. The lithography machine used in the Qingdao packaging and testing project is a packaging lithography machine, not a chip manufacturing lithography machine. According to a senior person in the semiconductor industry, the traditional packaging process does not use a lithography machine, and only wafer-level advanced packaging will use one. The research and development of the lithography machine used for packaging is much less difficult than that of the lithography machine used in IC manufacturing, and the market space is smaller. But the later lithography machine manufacturers can first accumulate in the packaging field, according to Foxconn's official WeChat news. The commissioning ceremony of Foxconn Semiconductors' high-end packaging and testing project was held in Qingdao West Coast New District on the morning of November 26. The project has entered the production and operation stage with the start of the first wafer-level packaging and testing production line. After reaching production capacity, it is expected that approximately 30,000 wafers will be packaged and tested each month. In April 2020, Qingdao West Coast New District signed an agreement with Foxconn to establish a high-end semiconductor packaging and testing project. The project's main body is Qingdao New Core Technology Company, Limited, hereinafter New Core Technology, which has a registered capital of 508 million yuan. According to Kixin Bayo data, New Core Technology currently controls approximately 46.85% of Qingdao Rongkong Technology Service Company, which is indirectly controlled by Qingdao State-Owned Assets. Foxconn affiliate Hongjing Technology controls approximately 15.75%, and its subsidiary Shenzhen Futaiwa Industrial controls approximately 11.81%. Chen Weiming, general manager of Foxconn's business group, serves as chairman. The construction of the New Core Technology packaging and testing project began in July 2020. The main body of the project was completed in December, as was the internal decoration. The installation ceremony was held in July 2021. And the installation and commissioning of equipment began, and mass production began in December. It only took 17 months from the start of construction to mass production, creating an industry miracle. This is also reminiscent of Gui Timing's spy for Trump in the United States, which did not materialize until Trump left office. New Core Technology announced on its official website on December 3 that it held its first lithography machine approach ceremony in July of this year. The lithography machine, according to the article, is a critical piece of equipment for semiconductor industry packaging plants and wafer fabs. In today's rapidly changing world, the New Core employs domestic lithography machines to ensure consistent production and expand production capacity. On-site photographs show that Shanghai Microelectronics produced the first packaging lithography machine with which New Core Technology entered the field, but the total number of equipment and specific technical details were not disclosed. Following that, on December 5, United News Network and other Taiwan media reported that Foxconn Group's first wafer-level packaging and testing plant, which was officially opened in Qingdao, had 46 Shanghai Microelectronics 28 nanometers lithography machines installed. The completion of technical testing and certification of the lithography machine in August, according to the report, means that Shanghai Microelectronics lithography machine has achieved a leap from 90 nanometers to 28 nm, according to the Shanghai Microelectronics official website. The company's lithography machine products are divided into 600 series lithography machines for IC front-end manufacturing and 500 series lithography machines for IC back-end advanced packaging. The latest model SSA 600/20 of the 600 series lithography machine has a resolution of 90 nanometers, while the minimum resolution of the 500 series lithography machine is 1 m. Shanghai Microelectronics has long made breakthroughs in the field of lithography machines for packaging. According to a research report published in June 2020 by Founders Securities, Shanghai Microelectronics has achieved mass supply in the field of packaging lithography machines. The domestic packaging lithography machine market share is as high as 80%, making it the main supplier. Shanghai Microelectronics packaging lithography machines are not only successful in the domestic market, they are also exported to overseas markets, with a global market share of up to 40%. Shanghai Microelectronics announced the release of a new generation of large-field high-resolution advanced packaging lithography machines in September of this year. The new lithography machine introduced this time, according to the company, is primarily used in the field of high-density heterogeneous integration. It has high resolution, high engraving accuracy, and a large exposure field of view, which can help wafer-level advanced packaging companies achieve more chip high-density interconnect packaging technology application. At the same time, we should consider the following question: how should China use lithography machines to break others' monopolies? To begin, continue to invest in self-research and patent cross-licensing. Patent barriers are one of the challenges in the development of lithography machines. ASML has 2 R&D centers in China and has applied for over 3,000 lithography-related patents in the country. As a result, if we are to achieve breakthroughs in lithography machines, we must increase our self-research efforts even more. Not only Shanghai Microelectronics, but also relevant domestic departments, enterprises, and institutions must strengthen and break down patent barriers for research and development through patent cross-licensing. We did a good job on this point. There are constantly new patents for lithography machines, but we must maintain our efforts. Second, capitalize on the system's advantages by establishing a coordinated development model. We know that integration is critical to the success of the ASML lithography machine. Because the majority of the ASML lithography machine's technology and parts are imported and then integrated, China has a large territory, abundant resources, and the system advantage of concentrating power to do major things. This advantage should be used to bring the two together. One approach is to incorporate capital investment. Not only rely on the state for investment, but also leverage social capital participation. The second is integrated research and development in technology. The lithography machine's core technology is difficult, and the investment is high, which is driven by the state, guides the participation of enterprises and institutions, and finally realizes technology integration. A lithography industry alliance should be formed to promote advancements in lithography machines. Third, prioritize talent development and avoid working behind closed doors. Domestic lithography machines are no exception. Any technological breakthrough is inextricably linked to talent. We must not only cultivate lithography talents, but also foster an environment conducive to the introduction of lithography machine talents. It is necessary not only to cultivate talents locally, but also to send them to advanced institutions for further study. Remember to stay away from developing behind closed doors. Previously, Nikon had been surpassed by ASML, which was to exclude TSMC's advanced ideas. ASML actively embraced and collaborated with TSMC, and both achieved leapfrog development and their current status. ASML, Nikon, and Canon have long dominated the semiconductor front-end lithography machine on a global scale. ASML, Nikon, and Canon have nearly occupied the majority of global semiconductor front-end lithography machine shipments from 2012 to 2019. The ASML lithography machine has a market share of 99% and a market share of more than 60% all year round, with a very stable market position. According to Founders Securities, realizing the import substitution of lithography machines cannot be accomplished by a single company. It necessitates the collaboration of top lithography industry companies. There are two parts to the lithography industry chain. The first is the lithography machine's core components, which include key subsystems such as the light source, objective lens, dual workbench, and immersion system, and the second is lithography supporting facilities such as photoresist and photomask, templates, rubber coating, and development equipment, for example. Thank you for watching today's video. Thanks for watching our video. We would appreciate it if you subscribed our channel and gave us a thumb. See you.